Okay, we're fine. Hello everyone. Hello Akram. Hello Itafi, Aladdin, Ayub, Yasin, Ingasi, Harp, Ezo, G_M, Kog, Onyinshi, Pascal, Fat, Ricky, Rokia, Said, Ahmed, Shadow, Sir M. Bank, TD, Jodros, Jesus, Chosen, Yaninte. Sorry if I ruined someone's name. Okay. What we're gonna do? We're gonna jump to. So we're in week 5, right? So Tuesday we did this. Wednesday we did this tree, and I believe this tree today, and tomorrow this tree. So let's start from valid anagram. Then we jump to binary search, then float fail. Okay, I believe we did this one, but it's okay, we can do it again. Okay, so let's read it. Wait, give me a second. I'm back. So given two string s and t, return true if t is an anagram of s and false otherwise. An anagram is a word or phrase formed by rearranging. Okay, how do I pronounce this one?
Rearranging
the letters of a different word or phrase, typically using all the original letter exactly once. So basically, if you have like 2a, you should have 2a here, right? Is that what's anagram? Someone clear that?
Yeah. It has to be a legit word. The second example is way easier. But essentially, yeah.
So this one is not anagram because there is air here. No, because there's t here, but there's no t here. So basically, anagram should have the same number of letters and same word, and order doesn't matter. This one is anagram, this one called nagram, but it's still set true. This one, rats and car, it false. Okay, I have a question about
so
this.
Even though it's one character, even though it's one character, so far the other one has one character. The same character is also an anagram, right? Like let's say the first string has A, the second string has A. Is an anagram, right?
Yeah.
Okay.
Because I think here the order is different, but if we count how many A there is, there's 3A. Okay, let's take it to our lab. Emmanuel, for if you can like with your mic, do you have like background noise until you wanna talk, and feel free to unmute. So this one have A. So A 3 times. What the hell? Okay. N 1 time. And G 1 time. R and M 1 time. R M 1. So if they have the same number of or frequency of character, then it is anagram. Okay. Is this clear for everyone? Please don't be shy to open mic talk or write in the chat. We all here learning, and it's gonna be amazing journey when we're gonna like finish week 6, week 7, week 8, 9, 10, 11. The last week is 12. we're gonna do this hard LeetCode together. So how you think we can do this? First of all, let's see what type of function they give us. So they give us this. Let's take it to the lab. So what they give us is a string and the target, or like this one. So S and T to return Boolean, true and false. So how we can do this? Maybe a hash map. This is look like a hash map.
Yeah,
We can do a hash map.
we can do the.
Wait, someone is talking, but it's low. The volume is low. TD. It's me.
Yeah, we can do the hash map technique.
Okay. Hash map technique. Okay. Let's try that. Now we can do it. Dun, 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 dun. So if we write our pseudocode, what's gonna be? It's gonna be like count this number, then count this number, right? And each number we're gonna put in the hash table, increment the same key.
Yes, exactly.
It's gonna take us what, 2 loop?
Yeah,
Okay,
I think the
2 loop.
time complexity maybe will be.
I think it's gonna be. Can we like do it with 1 loop? Any suggestion?
Loop, yeah. We can do it with 1 loop.
We can do okay.
One loop is fine.
Okay, how we can do it with 1 loop? We're gonna loop through this.
Yeah. At the same time, we
loop through this.
through this. Yeah.
Okay, so let's create a hash map. First, is this gonna be empty or
Empty,
not?
Yeah.
Maybe we can add first character.
Just meet it empty, I think.
Okay, let's go. For S, for car in S. Okay, wait a second. This is not gonna work. If we did like for this, it's gonna
Why not
be
use the
the E.
index?
index.
why
Yeah,
not?
okay. For E in range, let me zoom a bit.
First of all, I think you need to check if you have the same land.
Yeah, that's a good idea. Because if they don't have same land, they are not anagram, right? So
That's correct.
Yeah.
Okay. that's smart. So if length is not equal length of t, return what we supposed to return.
False. False, I
Oh.
guess.
So false. Now in case they are equal, there's chance they are anagram.
Bother say like sort them.
Can sort them.
Yeah.
Yeah, that's a good idea. You can sort it, then compare each of the characters. Finish. That's all.
Okay, can we do something else? Sort them, then check if the first equal to second. Okay, that is cheating, but that's smart. So
that's a fast method.
okay, so so we're gonna return. Are we gonna use sorted or sort?
Yeah. Sorted.
Sort.
I think sorted is cool. Yeah.
Yeah.
Okay, but
Sort.
what's the difference? We can try here.
There's no sort method, right? Sort is a method for is a method.
Your mic is a bit.
So sort is a method inside str. inside array list class.
Yeah, it doesn't exist in the string.
Oh, okay. I see what you mean. So sorted.
Yeah.
So- So if I did like E, B, so this, what's gonna say? Oh, I forgot. I think
String, yeah. So this will return a list.
maybe C. Okay. So it's sorted for us.
If you want it to be a string, just
Sorry, hope is not converting it. Hope is not converting it to a list.
It
Well,
is
just-
converting it to a list.
you use join. Use
There's
join
only-
to.
Because we are
To join
checking.
them, yeah.
No, but we are just need to check. So like,
Returning a boolean, right?
Oh yeah. We just need to check both of them. Sorted,
Yeah.
sorted. Yeah, it is the same.
Okay.
Exactly.
so if this is A and this is B, it's gonna still give true, right? Because it sort them, then we equal. We check if they are equal.
Yeah.
Yeah, that's the that's the best method.
So T return. Let's see. Run. Okay.
That's good.
What is this? Hacker. Badra is hacker. Okay, nice. It's accepted. But
Yeah, but
but I think okay. What is called? Your mic is hard to hear. I think you may be far.
nah, I'm right over my laptop, right?
Okay, it's hard to hear you. I don't know why.
Okay.
Can't. Do you hear him, guys? Well,
Nah, it's hard to hear.
maybe activate the noise cancellation in the Discord setting. But I think if we did like this, we're not gonna kinda learn that much from
Yeah.
this. So maybe we do it also in the. So the sorting approach work, but it's not the most performance. Okay, that is true. Yeah. What was the submission?
Do you know, guys?
30%.
What algorithms sorted function use to sort the string or the
This one.
It's an n log n, I think, in complexity.
N log
n.
n.
So n log n. So it use like binary.
I think this one can be less. This one can be better if we use hash map.
Yeah, I think so. Because it's gonna be n, just O of n.
Okay, let's keep going. So we did
Why
length,
not try using sets?
set.
Yes.
Wait, can you repeat, please?
Like you do a set of each of the
The problem with the set is
each of the
because
strings.
there might be repetition in characters. So you might have 3
Yeah.
A's or 4
But
A's.
then those repeated characters are supposed to be in the other one.
How would you be able to check the number of characters that were in? Let's just say, for
Check the
example,
number of characters. After
Yeah.
you check the length, if they match, I don't think you need to do anything again, because if the lengths are the same, that means it's most likely an anagram or not. If it's not an anagram, then those letters or those characters will not be in both sides.
Okay, so you are
so
saying
yeah,
pending.
what you just said now, yeah, there's room for a lot of bugs, right? They can be the same length and the number of characters, like say AA, BB, and then C, and the other one just has AAA, B, and C, right? The same length, but like the number of repetitions are different. In that situation, you get a true instead of a false.
Oh, okay. The set will reduce it to just 3. Okay.
yeah, so we have to check the character as well as the amount of time it appears.
And then hash map will do.
Oh yeah,
Hash
I
map.
think hash map it will work. So now we're gonna loop on this string, right? This one, and same time this one, because they have the same length. So what we're gonna do is so hash map, let's call it hash to make it short, hash, and then s e, right? Or am I mistaken? Something like this. So SE equal +1, or but so it needs to be 0 at first, so we can do +1. We can do something like, I forget the technique, like
We can first check if s of e is inside the hash. If not, then you put 0, and then if it is, we put +1.
Or
okay.
1. You can set it to 1 first. Yeah.
Okay, we can do that, but there is a way to do it without that. I just forget what it is. Maybe it's like a get. Maybe hash get. No, hash get. It's gonna save us some line.
Yeah, hash get in brackets the key, comma, and the default value you want it to set.
Yeah.
Exactly.
So this one is like, okay, go to the hash, get this one, but if you didn't find it, put 0. So when I was gonna put 0, I'm gonna add 1. Okay. Now we fixed that one. Huh? Now we're gonna do the same for the second one. Second string. Second string gonna be t. Wait. We are using the same hash map, right? So how are we gonna check if we use same hash? Do we do -1? Do we do like -1? So the hash map should be 0. Right? So if we have like okay, let me try this. I think both work, plus or it's just a check. So if I add this +1, I find it here, I'm gonna do minus, here plus, here minus, here plus, here minus. So then I'm gonna check if this is 0, 0, 0, 0, 0. If all 0, then it is anagram. If one of them is different than 0, then it is not.
Yeah, but
makes sense.
In the check, like you add another loop to check this, to check the hash map, to go through it again, the hash map, and check if it is like all the elements in the hash map equals to 0. But if you delete any already exist key inside the hash map, and at the end you're gonna check like if the hash map is empty. If it is empty, you're gonna return true. If it is not,
that makes sense as well.
Smart, genius. Okay.
Yeah.
So we add this, and here we delete it. Okay, I got the idea. We add and we delete, right? But how do we do it? Like
I think we okay.
Do we do check here? If it is 0, then delete. If hash, we can do a check here delete, but
Do we have to do it in another for
No, before you add, you have to check. Then before you add it, you have to check, then delete it. You're not adding it actually though. For the first time you add it, but subsequently, then you have to delete it. But my only confusion is, you have two strings. So is it the first string that you're adding, and is the second string is for deletion? So you need to see how to balance the two of them. Because if you're adding from the first string, then when you're doing for the second one, you have to delete it. So I think it's two loops. I don't think one loop can do it. But you can think about it though. Maybe one loop can do it. Maybe.
So, correct me if I'm wrong, Omar. So what you're saying, we added, then the second one we deleted. So at this time we have always an empty hash map.
No, we don't delete it after adding it. We need to check if the key or the character is already exist inside the hash map. If it is already exists, I mean by the key, I mean like the character of the string. Okay? If the character already exists in the key, we got in the hash map, we're gonna delete this element in the hash map. And we check again if the character of the string s already exists inside the hash, also exists inside the hash map. If it is already exists again, we're gonna delete it. If it is not, we're gonna add it. That's
I see.
yeah. Okay.
My problem here. Sorry, I have a question. Sorry. The thing is, that means you have to use two loops because you are working with two strings. How do you do them? Because you have to do the two strings at the same time. Do you understand what I'm saying? Based on what his solution, you're working with two strings in one loop. So how do you do the addition and deletion at the same time with two different strings?
Okay.
So I just feel that you should first of all add it first, then use the second one to do the deletion on a different loop.
I think this is what he's talking about, right, Omar?
I need to modify something. I need to modify something. I'm modifying something.
So he did like key in hash map, then delete the hash map key, else the hash map key something.
Instead, I think else we can
copy. Just copy it now. Copy.
Okay.
That's what I'm saying. If you do it like that, then that means at the end, you're still going to have some data in the hash map.
I think it's complicated.
Yeah, I think so. But okay, wait. Not that complicated, but if you want, like, you can add your mark there.
Okay, so we are trying to do it with one for loop. That's is the thing.
Yeah,
exactly. Which I feel it may not be possible.
Yeah, I think it's possible by using this. I don't know if instead of using here, in my code, instead of using tool, you need another statement after the condition is inside in hash table. The condition if si in hash table, you need another statement there. After there, I forget to add it. Deletion. It's a deletion.
Okay, do you have it in the here?
Yeah.
Okay, did it work? Did it work with the LeetCode?
I didn't like.
Okay.
I just put it here in the chat.
Okay, try it and let us know it work.
Okay.
We can continue with this method of the hash table, but so far with this method we're gonna have hash table that is like equals 0. Then we will have to loop through it and see. So we're still gonna have use to loop. So like the solution, they didn't say like don't use to loop or something. We are just like trying to make it a bit complicated.
Exactly.
Okay, so there is another solution. Let's see it. Okay, this one is
Actually, I like the guy's idea, but I just feel that one loop is not enough to achieve it.
so hash map character in string, if not plus one. Okay, this is also the plus minus.
Yeah, it's almost the same like the former one. Yeah.
But this one it deletes too. But this one was also using 2-4.
Yeah, I can't think of a way of doing it with 1-4.
Yeah, I don't think there is. I guess we continue with 2-4, and if someone solve it with 1-4, we can check it out. Okay, so from here, now we have a hash map that is have all the character. We just need to add another 4 here.
Is there no way of checking in Python the equality of two dictionaries?
Can you repeat?
In Python, is there a way of checking if two dictionaries are the same?
Dictionary is the same.
You
If
can
like
test
one
it. You
dictionary
can test.
equals...
You can test.
Not sure. How
you can test
to
it.
check if two dict
If they have the same key and valid pair, you can just do a test and see if it's going to work.
Way. Let's see. So there is equal. Okay, that's good to know. You can do equal. We can use CMP. We can use all and loop through them. Oh, we can. Okay, so straightforward is equal. I guess we can.
Yeah, equals should be all we're doing, right? After we've added both values into both hash maps, we're just taking
Oh, so
equality
two
after that,
different hash map.
Yeah, two different
But
hashes.
is the order gonna matter? So we need to sort them maybe? Because...
Oh, do we?
You know what I mean? So like
I hear what you're saying, but I doubt
You can
order
ask
matters.
ChatGPT if the order of the keys matter, or you can just test it here.
Yeah. So like if we did this... So if we put this here... Is this gonna still be equal?
I think it's the same. It's the same.
Yeah. So it doesn't matter the order. So the keys... Okay, this is good. So we can just loop, but we're gonna do two hash 2, and just use the hash 2 here. And
so what's gonna be your what will be your value? Sorry, is it 1 or 0? Your values for your keys.
Can you repeat? 1 or 0?
I said, what will be your values for your keys? Are you going to use 1 or 0? Which, because now you are adding it in two different hash, right?
Oh,
string
should
1 will be
be
in hash,
plus 1
hash,
for...
string 2 will be in...
I think the value... Wait. Yeah, plus 1 for both. Because the minus was only working for when there is 2. Same. Okay. Okay, I guess we did it with 1 for loop. Nice, Ningas. The genius. Let's see if it works. Maybe we are early.
Your return. You need to check your return. It's hash. Your return.
Oh.
Hash equals hash 2, not hash 1 equals hash 2.
Okay, yeah. Hash. Okay, so run. Ooh, submit. See how much the other one was. 72, much better than the other one. Nice. Okay, that's a good idea.
That's a great idea. The only drawback here is the memory
Yeah, to hash map.
to hash map. Yeah.
Yeah. Okay.
Anyway,
Let me clap for this quick. Wait, why don't there? Okay.
Congrats, guys.
Congrats. Okay, so we finished this one. This one is easy. We did this before, but it's good to refresh our mindset. Now, we jump to this one. This one is not easy, probably. Okay, they are saying it's easy. So,
can I?
Yes, go ahead, please.
Can I ask? Yeah, it's in the in our previous in the hash map. Yes, much.
Yes. You want to come back in?
Yeah. So, what's the gate? The hash dot gate.
Okay, so hash dot gate, it's gonna go to the hash and check for this value, for this key, and it's gonna bring the value to us as a return. And if it didn't find it, it's not gonna give us error. So when you are accessing the hash map like this, let's say I'm doing print dictionary of Z, right? You see this error? But if I did use get, there's no error, none. So your program is gonna keep running, there's no error. But we are using it here to also get this this function, this feature is or whatever. Is like if we didn't find Z, I can set a default value return 5. You see, it's return 5. So in our case, we did return 0.
0, yeah.
And then we did add to it a value, because if this one doesn't exist, we can't add 1 on something that doesn't exist.
Nothing exists. Okay.
Yeah. So yeah, this is a cool trick.
Okay.
Now let's jump. Yeah, is it clear? Is anyone have more questions? Let's jump to this one. Binary search. Given an array of integers, nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return its index. Otherwise, return -1. You must write an algorithm which O log n runtime complexity. So I guess we are familiar with this one, right? The binary search, which means like we're gonna have a middle, high, low, then split it in right or split it in left. It depends where our target. Let's take it to the lab and process it. Okay. Also, this, if we did go fast on this, just check the, I think the one of the PLD we did this. Which one was binary search or something? Matrix Q, I think 3.
Yeah, we did it one time.
Either 3 or yeah, binary, this one. Check the binary PLD, we did go in detail on it. But now let's do it quickly. And so we have target is 9. We know 9 is here. Index 4, we should return 4. And because they said O log n, so we need to, each time we loop, it's like we reduce the size of the area we are looping. So how we can do this? How we can do this? Any idea, guys?
The binary search, by using the binary search, splitting the array by 2 and check if the middle element is greater or lesser than the targeted number. If it is greater, we gonna like put the pointer of the start in this number, and if it is lesser, we gonna put the pointer of the end on it.
So are we not supposed to sort it first, or is it all the arrays have been sorted already for us?
Yeah,
I believe it's they say it's sorted in ascending order.
Yeah.
So
Okay, nice.
Yeah.
Nice.
So what we're gonna do is, if we write pseudocode, it's gonna be we need to set low, let's say low to 0, high.
We need 3 pointers, right? Okay.
3, yes.
Yeah.
So high is gonna be the last element, which is length of what is. I think someone, Eric or Baga, you have mic open. Nums. Nums is our nums. Okay. So length of nums. Length of nums. Right, now we have this pointer, and we need to find the middle.
Yeah, it's length of nums minus 1. I think we have to.
Middle is -1. Yeah, so because this gonna
the
say
last element.
okay, because it doesn't start.
Because it starts with 0 to find the last element with -1.
Yeah. Okay, so this can return 6, but we start from 0, so it's gonna be 5. The middle gonna be what we do, low plus high, low plus high,
divide by
plus 2, but we should do this because the priority, and then we do a while loop. So while loop is gonna be like looping until the low is
less than or equal to.
It's gonna be looping as long as the low is less or equal to high.
Exactly.
So we can do while low less or equal high, then so we need to keep sitting middle, so we probably should do this inside, because every time we loop we need to have new middle. Now in this case our middle gonna be 3, right? So we need to check if 3 equal the target. The target we give to us is 9. Okay, now if
we can find it at the first loop, then
return it, right?
Return the
index, yeah. Return targets. I think it doesn't matter.
Mid, yeah, the index, because it says the return the index.
Oh, the index, yeah, you're right. Okay. So
then,
if in case this one is not equal to target, then we either need to split the next loop, either should start searching from this side or from this side. Now we know that it is sorted. So if this one is less than target, that means the target is still, wait, if this one is less than target, that means the target is in this side. If this one element is large or like greater than target, that means the target is gonna be in this side. So in this case we're gonna do if
else if
or if
else if, because it started with if, then else if then else.
But
You can you can say,
because if we enter this one, so because if this is true, we're gonna return, right? So we can do just if, right? Because this is kind of like separate block.
Yeah.
No, it's the same. It's the same block. If you can find the target. If not, we have to check if it's less than or greater than the target.
Yeah.
So they are
Anyway,
but it will still work.
Anyway,
right?
yeah. Anyway, it will still work, yes, but anyway works. Anyway.
Okay, let's do elif. Then we need to check, as we said, this number if it is less than target. So we know that number is inside array nums and it is the middle, less than.
Forgive me, I missed it, but the list will always be sorted, yeah?
Yes.
Oh, okay.
Wait, this is not elf. What the hell am I writing here? elif. Okay. Now, if it is less, that mean what that mean? If this is less, that mean the target is in this area, but we can remove this because we already checked this, so we can specifically check between these three. And because our high is already set up here, we only need to move this one to here. So basically the low gonna have new value. It's gonna be mid plus 1 because mid is here and they just add plus 1 to be here. Now if it is not true, else, which mean our target is greater than 9, which mean we need to search in this area. Then basically we need to move this high to here, which mean high equal mid minus 1. And basically it's gonna keep looping and splitting the array on pieces, and at some point it's gonna return the middle. If not, we should after return minus 1 if the loop looped through everything and didn't find it, then we're gonna return minus 1. Okay,
that's correct.
Let's check it. It work. Is it correct? Okay, submit. Nice. Okay. It worked fine. Now we can do it also with the dice. If someone watching,
Congrats, guys.
If someone watching, probably
this is the best PLD so ever today.
No, because we did these topics before. It's kind of easy for us to to follow it.
Yeah.
But if someone is struggling, didn't understand, just watch this binary, and yeah, you will be comfortable with this. Now let's make this one harder, and let's make it with recursion. How are we gonna do this? We can use the same thing here and try to convert it to recursion. So let's see. So recursion is gonna be a bit tricky here because we only have nums and targets, and each recursion we loop, we should send new low, new high. So we will be forced kinda to create our def. So let's see, let's write it here. So what we start with the base, right? What is the base for our recursion? Or basically where the loop should stop. We have high, we have low. the loop should stop when this low is exceeded the high, right? As long the low is doesn't go outside of high, we can still loop in. So basically the base is low. If low exceed, like, greater than high, then return -1. Okay, here is the base is done. Now when we're gonna launch recursion, we need to calculate the middle. The middle gonna be the same formula, which is this one. So just copy paste. And we need also to check if it is equal, so just copy paste. After we calculate the middle, we need to check if it is true. Now if it is not true, now we're gonna send 2 recursion. No, 1 recursion. It depends on this condition. So let's copy this condition here. Now here it's gonna be a recursion, and here it's gonna be a recursion. So recursion, we need to send low. Let's say we did because okay, how it, okay, let's say search. Okay, let's do just search, then we can, when we code it, we're gonna see return self.search. We need to give it nums. We need to give it target, but also the high and low. Okay, remove this. Don't need it. High. So let's give it high first. And the low is gonna be equal mid plus, so we can leave it like this. Low, mid plus. Now the same thing for this one, it just we're gonna change the high instead of low. So the low gonna stay the same here, gonna stay low, same value, but the high is gonna be mid plus 1. I guess that's all. But the problem is we don't have this, so we need to create. So let's call it search2. Search2. And then we copy it. We remove this. Let's create search2 first.
That's a helper function.
Yeah. And this one's gonna have low or high first, then low. Then low. And here. So here we're gonna call, is it return? Yeah, return self search2. We're gonna give it nums, target, and high. How did we calculate the high before? The high calculates with the len nums -1, so we can use the same thing here. And how we calculate the low? Low, we give it 0. High, low, return, run. Okay, nice. Submit. I think this one better performance than the other one. Okay, so that was how to convert this iterate function to recursion. I hope you guys understand. Yes, boss.
I'm a little curious. If you could just go back to the LeetCode
yes,
to your score. if you just click on the chart, the graph, no, you go back to solutions.
Solution.
And then just on the graph, oh no, it was a submission, sorry. On the graph, just go to the first one there, the very first, and then click on that submission. Let's see what the fastest did.
Can we see which code is this? Python. Is this Python?
I don't think that's Python. That's why he was so fast. Okay.
Wow, what is this? What
That looks like
language
C.
is this?
I think it's Python.
Maybe the charts will show us only Python. The provided code is Python.
Yeah, it's Python.
Wow, wow. Zip. Okay, explain.
He's using a file.
Shortly. Yeah,
He's using a file to do what he's doing.
That's amazing. There's a lot to learn. The code open a file named user out for writing W mode. It iterates over a pair of value n t from the standard input using zip std. For each pair, it extracts and processes the value. The first value n expected to be a comma separated list, presumably of an integer, and the second value t is expected to be an integer. The code performs a binary search on the list of integer n to find the index of target. The index z is then printed to the file the program exists. How did you even get this idea? Like, imagine you are asleep, eating your breakfast or something out, and you're like, oh, I know a solution to do it. I'm gonna open
This
a
is
file.
Madness.
I'm gonna do this. Oh, amazing. Okay. Who have any question about? Okay, let's see the slowest idea. Wait, why is this slow? Wait, this almost close to the first one we did.
Yeah, I don't know why these ones are so slow as opposed to zipping.
I don't know why this is slow. Maybe because
it
this
depends
one.
on how they do this. So yeah, something like that. I think it depends on how you use the memory or.
Oh, maybe this else right here. Length. Yeah. Okay. This is gonna be a rabbit hole to go through.
Yeah, some other time, yeah. But it's
okay.
always interesting to see what other people are doing.
Yeah, it's really nice. Okay, please, if anyone have question, something, we're here to learn. Don't be shy. Before we jump to this one, float field. I guess there's no question. Are you sure? No one? Everything clear? Okay, let's keep going. So, let's start fresh page. Now, float field. An image is represented by an mxn integer create image, where image ej represent the pixel value of the image. You are also given three integer sr, sc, and color. You should perform float fill on the image starting from the pixel image sr, sc. To perform a float fill, consider the starting pixel plus 101. Okay, I see a red card there.
90th minute, what a game.
Plus any pixel connected for directionally to the starting pixel of the same color as the start. Okay, to perform a float fill, consider the starting pixel plus any pixel connected for directionally to the starting pixel of the same color as the starting pixel, plus any pixel connected for directionally to this pixel also with same color, and so on. Oh my god, this is so hard to understand. I'm sure when we're gonna read this, gonna be clear. And so on. Replace the color of all of the aforementioned pixel with color. return the modify image after performing float fill. Okay, so what is happening there? So we have image 1 1, so it is array, it is a matrix. We have SR SC color 2. So SR SC, okay, and then we give this output. So they give us this, we return this. What happened? Explanation: from the center of the image with position SRSC, okay, so this one 1 1, the red pixel, okay, so this coordination, all pixel connected by a path of the same color. So same color here is 1, so the number is color, the same color, okay, as the starting pixel, which is 1, connected by a path, example the blue pixel, okay. Okay, so this one is connected to this one, but this one have 0, so it's not same color. Connected to this one have 0, not same color. Okay, connected to this one, it have 1. But also this one is connected to this one, have 1, and this one is connected to this one, and this one is connected.
Do we do a depth first search or breadth first?
We do them both. We do DFS first, and then we do BFS.
Okay.
Now, the starting pixel are color with new color. So, not the bottom corner is not colored too. So they give us this one, and it's become like this. So this one become 2, 2. This one become 2, this one become 2, this one didn't become 2 because it not same color. This one have 1, this one have 0. This one didn't become 2 because also difference, it have 0. And because this one also changed to 2, it's also gonna change this one to 2, this one to 2, and because this one changed to 2, it's gonna change this to 2. It's like a virus, if you remember. We did this, something similar to this. Now, why is this didn't change to 2 even it is 1 here? I guess because it's not connected by a path of the same color, because there is like a not connected here. It's disconnected. So let's take this to our lab and try to understand it more. So we do. Okay, so we have 1 1 1 1 1 1 0 1 0. So this is the so SR1 is like the row. So this is row 0. So this is row 0. This is row 1. This is row 2, column 0, column 1, 2. And so SR1 is, so this is SR. This is S column. So 1 is this. So this column and this row with this column. So this is the source. Now they give us this and they say from the center, or like to perform a float fill, consider the starting pixel plus any pixel connected for the directional. So we're gonna start here. We're gonna change it to 2, and we're gonna all, what that word? connected for directional, which mean this one right here, this one, this one, this one, right? But this one is not same color, so we're gonna ignore them, and we're gonna only change this to 2, this to 2. But this is like a virus. If when this change, they also connected for directional to this one, to this one, to this one, and to this outside the limits of the matrix. So this also gonna change 2, it's also gonna change 2, and again this gonna, and because this also like connected to this gonna also change, but this already changed. And also this, when it change, it's gonna change this and this and this and this. Okay, is it clear? Like the idea? And this is like a DFS, right? Like
Yes, sir.
Ingas said. So recursion, let's try to do it with DFS first, and then we try to do it with BFS. Also, if someone not familiar with DFS and BFS, there's this PLD 09. We did go through DFS and the BFS in slow motion, so you should be able to understand.
Yes, refer to the text.
Oh, which one?
I said they should refer back to the videos.
Yeah. Let me paste it. Let me paste the playlist. So this one is DFS and BFS. Okay, how are we gonna do this? How do we start DFS normally?
So you say you're doing recursion. I'm not too familiar with the recursive way, but I remembered we had an array that holds the nodes that we visited, or at least the pairs that we visited, as well as the direction. We need an array for the directions, right? The 4 directions that you can go in.
Okay, let's copy this so we can have idea what we're dealing with. Okay, so we have image, we have SR, S, and color. So color is the new color that we're gonna change. 2, right? So 2, here it's gonna be 2. And this is the direction where we're gonna start, 1, and image is the whole array. So let's first okay, trying to remember. Let's create DFS, then we can try to connect it. So DFS is gonna be like what? DFS. It should have coordination, right? So because it's gonna go through H1. So let's say row colon. I think we start like this, then it's gonna start. Okay, so now DFS starts. It starts from this center. Now we need to check if this center. Okay, let me remove this noise. Okay, so we need to check if this one is equal to color, right? If it's equal, we don't need to change anything, right? If this 2, if this is already 2, there's no need to go through this. It's already 2.
Absolutely.
Okay, wait. So this we can do it outside of DFS. Like if what is this color? Okay, if how we can get the center? It's gonna be okay. It's gonna be like image. S R S. So this is the center, because, or like this is the coordination they gave us. We're gonna check if it is equal to color. Wait, to color, right? Color. If it's equal to color, then return. What are you gonna return? 0 or what? We're gonna return the same list. So we return a list. So we're gonna return the image. We're gonna return the same array because there's no need to change it. Now we're gonna start our defs, which mean here the number here or the color here is different. So we need to float this. How are we gonna do it? We're gonna check if this color. Okay, we need to a baseline because it's a recursion kind, right? So we stop when the color. Wait, do we need a baseline? Okay, when, let's ask this, when I want this recursion to work, when the color
is not equal to the target.
Is not equal to the target. Okay, so we can. Okay, I'm having a hard time.
Actually, I don't know. If, say, the one above it is a 1, sorry, is a 2, and then the one on the first row is then a 2, do we then? No, in fact, no, that's fine. I think, yeah, we visited if it's not equal to the target, right? Because we then have to change it. And then we'll check to see if when we get to that particular node, that in turn needs to be changed again. So that can work recursively, I believe.
Okay, I found it. Okay, I lost it. Oh my god. Okay, we can think about it like this. I'm not sure if that's what you said. Because I was thinking while you were talking, so I'm sorry if I missed it. Can you like repeat again?
Okay, I was saying you have to check, right? We start from the middle, right?
Mm-hmm.
And then we check each direction, right? And then if the direction that we find or we're checking at that particular moment, if it's within range, right?
Oh, okay. So first it have to have 1. So we need the way to check here. That's the defs we're gonna launch is the value is 1. So we need to check if R and C have the value of 1. But how do we know 1? Because we already have this.
Yeah.
So we can like
it's the SC value.
So we can like old color equal image source, or like even like this and do old color, and then this old color is what's gonna give us. Now if this new coordination we're launching on it, which is gonna be image air C equal old color, then I definitely need to change it. So it's gonna become image I need to put the new color, which is color, right? Color.
I think it's target from the function.
Wait, it's called color.
Oh, forgive me.
Wait, why do you call it color?
color is the one I think that we want to change to, right? Our
Yeah,
target.
it's let's say new color, just so we don't. You can change it later, just so we like stay more focused. I think new color is so. What we did here is like, because we know how DFS work. We know if I launch DFS on this one, it definitely gonna check this and this and this, because that's what we were intending to do later when we're gonna add coordination. Now I don't want to waste time here and here because this have 0 0. So by doing this, I am only checking this and this because it have 1, and because it have 1, when I'm gonna enter it, I'm gonna change 1 to 2. So this one is have 2 2 2. We still have this and this and this, but when this gonna launch, it's gonna affect this and this. When this gonna launch, gonna affect this. So we did this. Now we changed 2. Now we need to change. We need to like launch another DFS on, or like launch another recursion on this and this. Let me clear this. So basically this line gonna change this number to 2, and now what we're gonna try to do is to launch somehow this function recursively on this and this. We don't want this, we don't want this. Okay, let's see how we're gonna do this. So we need direction. Now direction gonna be, we did use that time tuple, I believe, right? Tuple of tuples. So what is this direction? It is R. It is okay. So this C, this is R. This is R. So R minus 1, and C doesn't change, right? So this is gonna be R minus 1, C. This is our first coordination. Now another coordination is gonna be the one under, which is R plus 1. Same C, R plus 1, C.
Absolutely, that's up and down. Now we have to do left and right.
And left, it's gonna be again R doesn't move, C minus 1, and R doesn't move, C plus 1. So this is direction to launch DFS on this, but we can add condition to like eliminate this, because in our case we don't want a 0. So basically we can let this right here, this function, I mean, because it's not gonna matter, right? Because all of these are inside this. So even if we launch a DFS on this one, it's gonna come to the here to say, is this image color equal the old color? It's gonna be false. So nothing gonna happen because this is 0 or the old color is 1. They are not equal. So we're only trying to affect the cell that have 1 to change it to 2. So basically we don't need to care about the value itself, but we don't want to be in this case. Imagine we launch DFS here, so automatically it's gonna launch one here. So it's gonna launch once outside the matrix. So we need to eliminate this. So to eliminate this, we need to add condition. to keep the defs inside the matrix. So if let's do the, so this is a row, this is colon. So how I can get the max of, or like max of a row? We can do length, right? We know a row start from 0, and we know, so it limits it by 0, so index 0, and error, I want to see that error, wait, no, not error, and it's first to loop on direction, right? How I can loop on this direction? So for say new, or like let's call it new row, new column, right? In direction.
Yeah.
So now I am having okay. Okay, so now I am looping through each direction, and I'm gonna launch defs on it. But before, we're gonna check the limit, right? So if f0, okay, so we have rows, row 0, row 1, row 2. Then we have colon 0, colon 1, colon 2. Now how I can know the row? So row is row 0. Row, so row 0. So this gonna help understand how I can see the limit. So the row is starting from 0, 1, 2. So row is the length of the array, right? So we can do length. So between 0 and equal inner length of
greater. Yeah. Also, it needs to be, NR needs to be greater. Sorry, the order messed me up. Sorry.
Yeah, it's okay. Greater, right? Because this one is gonna give us 1 plus.
Absolutely.
1, 2, 3. This is gonna give us 3, but index starts from 0, so it's good. Absolutely. If you did plus, then you should do -1 here. Okay, now we found the limit of rows. Now, at the same time, which means end, it should be not outside of colon. Now, how we can find out the colon? Colon is inside, so we can basically just calculate the length of this one, or this one, or this one. They both have the same length, so we're just gonna start from the first one, which mean 0, and again equal NC and length
of num0
nums, but index 0, so the one that's inside it. Then okay, this gets
I think it's image instead of nums. The input is image, not nums.
Image. Oh yeah, I'm still doing the other LeetCode, the one that was behind. Okay, you're right. Image. Okay. Wait, did I use nums somewhere else? Okay, image. So this condition gonna give us yeah, so this condition gonna give us the, then we're gonna launch DFS on it. Right, so then DFS, then NR, NC. Okay, so this is our DFS. Okay, let's try to explain it again just quickly if someone tried to catch up to us. So here what's happening here. Let's see. So we said we're gonna launch DFS on this first one, okay? Then it's gonna check if this image RC, okay, alt image RC, image RC, okay, RC is this, image RC, alt color is okay. So basically, because when we're gonna launch DFS, we're gonna launch it on this, and we're gonna pass coordination to this, right? And we're gonna see if this one right here is have the same old color, and because the first one is gonna be the same, so it's equal, and because it's equal, we're gonna change the color. It's gonna become 2 like 2 okay. Now it's become 2. Do we stop there? No. Why? Because we should also change this and change this and change this and change this, because this is the four directional, right? But because this have different color, which mean different number, we don't care about it. But our algorithm should be do this trick, or like this like change, or like it is this direction, because this is how we can change everything. So we can ignore this 0 by this check right here. If the color is same as old color, then you can enter this loop. If it is not, so this one gonna ignore it, And now what's gonna happen next? What's gonna happen next is we set up this direction. This direction is what's gonna allow us to move to this new area, right? Now we set up them, and then we're gonna launch. For we're gonna launch a for loop on this direction. What that mean? That mean I'm gonna my code gonna run with this direction, then this direction, then this direction, then this direction. So I'm gonna run DFS 4 times right here. And of course I don't wanna exceed the limit of the matrix. That's why we did this. And then we're gonna call DFS on the same one. So if we call DFS on this and it affect this, that means when we're gonna call it on this one, it's gonna affect this, and we call it this one, it's gonna affect this. So basically we're gonna change all of this to 2. That's what we want. Okay, let's continue. Is this our code? Is that all? We still need to call it somewhere, right? So down.
Are we not keeping track of the visited nodes, just so we don't have DFS going back on itself?
Yeah, we can do that. Wait, we check with this, because when we change it, it's not gonna.
I see what you're saying. By changing it, we don't have to then worry about it being done twice. Okay.
So here we're just gonna call DFS and then call source, or like SRS. And then this gonna start from the first node. I think this is all.
Let's try it.
Okay, let's go. So this is DFS. We're gonna try to do it also with the BFS. If this one work first. Okay. Okay, Wait, look, I did something. I changed new color. So the new color should be color. Okay, run. Oh wait, we didn't return. So we did launch this.
Yeah, then we need to
Okay.
return it. It's an in-place algorithm, right? So we just need
Okay,
to
return
the...
image.
Yeah.
Okay, because this gonna change the image directly. So run. Okay, let's go. Let's submit. Nice.
Boom.
Nice. Okay, I hope you guys understand it because I don't. If someone have question, please go. Please, if you have question, go ahead. And I'm sure if you watch this
Nice
tree,
job, guys.
yeah, that was a good one. Now, how we can do this with BFS, which mean Q? Let's try it. Let's try it with Q. Okay, so this one with Q, which mean not recursion, which mean like iterative. Okay, so this is with the recursion. So this is the FS. Now we wanna do it with Q, which is BFS. We can use the same code, just change some stuff.
Yeah.
Let's keep this close to us, just so like we remember. Okay, so BFS we need a Q, right? And because we start from 1, it's gonna be the first one here. And I'm gonna do while loop, while Q. So as long as I have something in Q, I keep looping. So let's start from that. While Q. While I have something in Q, I'm gonna keep looping. But before, let's set up a Q first. Q. Q. There was a function called DQ or something, right? The DQ. DQ. How do we do DQ? Let me see. Python DQ. Really?
One of these good days we should go over this collections library.
Collection?
Yeah, you import from collections DQ.
Okay, collection. DQ. DQ. Whatever, we can check it later. And what we can put directly the first node, right? For example, here we call it old color. Old color, we can do image, SR, SC, and then just put. But says, do we do a dictionary? I forgot.
No. You have to put the row. Yeah, a tuple. You can put a tuple for the row column combination.
Okay, so SR, SC.
Yeah. And then you also have to keep track of the visited nodes, I suppose. Or we can remove that.
Or we can do the same technique. Just check if color.
Yes.
So old color, we can do the same condition here. If old color, then return image, and then DQ we put the value. Okay, so this is, I forgot, is this gonna put the value or gonna put the coordination? It's gonna put 1 1, right?
Yeah, it's gonna be a coordination.
1 1.
Yeah.
Okay, 1 1. Okay, now inside the while, I believe we should pop. We should pop. So we're gonna pop air.
And remember to
call
pop
it
left.
air C. We're gonna pop Q.
Yeah, from your queue. I think you're
Pop
popping
left.
left. Yeah. Yeah. Yeah.
So pop left gonna take this element out, and we're gonna process it. And the queue gonna be empty now because this is our first element. But using direction, we're gonna add more queue to it if it's connected. So because we remove this one, we add it to the queue. Then we pop it. When we pop it, we're gonna add this and this. As we did in recursion, we were adding these 4. We're gonna do the same here. We're gonna add them to the queue. 1, 2, 3, 4. But because this one we don't need to add it because it doesn't have the same value. So this one we're not gonna add it. Or maybe we can add it, but because we can use this condition, image equal old color, we can just skip that loop. Probably not add it, better. So we have the RC. Now how we can add this and this to the queue?
We have to do the same thing you did with the directions, I believe, to find the neighbors.
Okay, before we do that, let's do the same thing. If image, like the same thing here we did, it have to set up like the color. It have to be old color. And as we did before, we're gonna change it to the color, which means image air color, because this was 1. Now that we pop it, we're gonna process it. The first thing we're gonna process is let's change it to the color 2. So now it's equal to. Okay, is that all? Yes, that's all, but we need to add 8 children. So we're gonna use probably the same direction code. Let me just copy it. Yeah, it's the same. So this is the same, just instead of like launching a DFS, we're gonna append to the queue. So queue append. Now we want to append with nr and c. If so this right here. So we have this direction. We did change the color of 2, and now okay, it have this and it have this, it have this and this. We need to append them to the queue to process it. But because we did this condition here, if, which means this gonna be inside if, which means only append if it have 1. Okay, I guess that's it. Then we return the image. Return image. Let's see if it's gonna work. Okay. Let me repeat this one more time. Someone trying to catch up. Okay, let's see it. See if this makes sense or so we said we create color image. This is just to make it easy for us to read. Then we're gonna check. So old color gonna be this one. So because we are changing the old color to new color, so we put a variable called old color. We put 1. We know that we are changing only one. Then we're gonna check if old color equal to new color. If this equal to, there's no need to change anything, just return this, right? That's what we did here. Then we create a queue. Okay, here's our queue. Inside this queue, by default, we put the coordination of this element. Okay, let's say this, let's call it this one. Now we enter the loop while queue, which is, this is commenting, or this is the algorithm of BFS. We keep adding elements, and as long the queue is not empty, we keep treating, popping each element out, do some treatment, and we probably from that element we're gonna add others element to here, and then we're gonna keep popping them out one by one until we finish. And then now R C Q, so we're gonna pop this element, right? Here's it, and because it is a tuple, have R and C coordination, we take it out, and we're gonna see if it have the same old color. So if we are treating this one, it's gonna skip this if, right? So it's gonna loop again to the next element. So this one, it's gonna skip them. Let's say it is in this one, it's gonna say yes, it's equal 1. Okay, come here, it's gonna go to the second line, which is this one. What this line gonna do is gonna change this to as it this to this. Then we have direction. Now this direction just to get the elements that are children of this 2, and we put this condition here to not take the element outside of matrix, and we're gonna append to the queue, which means this element right here, this element right here gonna be appended to the queue. Then we loop. We see, is the queue still not empty? Yes, it's still not empty. Then we do the same thing. We pop this, we treat it, we pop this. I guess hope this is clear. Please, if you have question, jump to the mic or chat. Now let's see if this is gonna run. Okay, we have problem here. Probably the imports, right? Import collection. Okay, maybe not collection. How do you write this? Okay, not DQ. It's like DQ like this, I think. DQ. The hell? Okay, yeah, there's DQ here. Q. Wait. Q. Maybe because tuple? Yeah, because tuple. Yeah, because we need tuple. Okay, run. Okay, finally. Okay, let's submit. 92. Ole, let's go, guys. Nice. Hope you guys.
Impressive.
Hope you guys did understand. Okay. Who have any question or anything? That was it. That was the 3 LeetCode for today. Let me post the code. Okay. Okay, who have any question, please don't be shy. Tomorrow we have another 3 LeetCode, which is lowest common, balanced binary tree, and linked list cycle. It's gonna be fun. Okay, I guess we See you guys tomorrow. Have a good night. And tomorrow, same time,
Thank you so much, Nex.
we do them. Thank you too, Nengas. Thank you, everyone. See you next time. Bye.